Alright, so if I was to ask you to graph y equals x squared, more than likely you would come up with something like this. You create your axes, and then you might even label them x and y, and the graph itself would look something like this. Question is, are there other parabolas? Can parabolas look different than this nice perfect yellow one here, y equals x squared? The answer is, of course, yes. Parabolas can be wide or thin, they can point up or down, they can start at any point on a graph, but how do we know where they're supposed to start? Well, this might seem like a bit of a sidetrack, but perhaps we can engage in a bit of an activity here. If I were to draw a dot here, and then I was to say, can you draw that same dot 3 points up? You would probably go, well, of course, 1, 2, 3, I would draw it there. So we draw it here. And then I would say, well, okay, now can you draw it 4 to the right? Yes, 1, 2, 3, 4, here I am to the right. I would draw it here. Now if I said, okay, now draw it 2 down and 2 to the left and twice as big. You go 1, 2 down, 2 to the left, and twice as big. That's not too hard, right? Well, if you can figure out how to do that, you can figure out how to do transformations. You can figure out how to move a parabola around. So before we understand how to move a parabola around, one thing you need to know is how to write a quadratic relation in the proper way. So there are a couple ways to write quadratic relations, and the one we'll start with is vertex form. And the reason we want to start with vertex form is because vertex form tells us pretty clearly where the vertex of the parabola of that quadratic relation should go. So this is vertex form. Y equals a bracket x minus h squared plus k. Now, you're probably saying, well, hey, that looks a whole lot different than y equals x squared. And that's true. It does. There's a reason for that. So this looks a little bit different than y equals x squared, but actually they're pretty similar. A, h, and k are just 3 different ways to transform that parabola. 3 different tools you can use to move that parabola all around. So to start off with, I'd like to just talk about A. So when A is positive, the parabola points up or smiles, and when A is negative, the parabola points down or frowns. So for instance, if I write something like this, 3x squared, that 3, the coefficient before the x squared, that's the A. And you might be saying, well, hey, that doesn't look the same as y equals a x minus h squared plus k. Well, it might not look the same, but it actually is the same. So if the only thing we have, if the only transformation we're going to apply to y equals x squared is this 3, this a, that means that h is 0 and k is 0. So to prove it to you, if I go like this, if h is 0 and k is 0, that pretty much simplifies down to exactly the same thing as y equals 3x squared. So it's the same thing. Good enough. Okay, so y equals 3x squared. What does that do to the graph of y equals x squared? So here's my kind of crooked graph here. Let's try that again. Okay, so here's y and x. Now if this nice parabola is y equals x squared, which is kind of our standard parabola we always start with, what does 3x squared, oh, I shouldn't be asking 3x squared. What I should actually be asking here is negative 3x squared. Okay. And to simplify matters, let's even just say negative x squared. Okay. So what does having that negative there do to our y equals x squared? Well, if we can see right here, when a is positive, the parabola points up, which is it is here, right? There's a positive 1 in front of that x squared, right? You just don't see it. And when a is negative, the parabola points down or frowns. So all this negative is going to do to y equals x squared is simply turn it upside down. So we can just draw it like this. So when a is negative, it turns the parabola upside down. And that's all it does. Second thing that it can do is it can make a parabola wider or narrower. It can compress it or it can stretch it. So let's look at an example of that. So again, we'll draw our perfect little y equals x squared. Here it is. Now, what about y equals 2x squared? What's that going to do here? Well, before we draw it, why don't we take a look at a table of values and see if we can guess what it might do. So we have our typical negative 2, negative 1, 0, 1, 2. Okay, so negative 2 squared is 4 times 2 is 8. Negative 1 squared is 1 times 2 is 2. This is going to be 0, always tends to be. And then there you go. Now what you notice is that actually in y equals x squared, these numbers would not be rising so quickly. And so because y is going to get bigger a lot faster, we know that this is actually going to go up like this. So even though your intuition might have told you that y equals 2x squared, well 2 is bigger than 1, so it must be wider. Actually the opposite. Because y gets bigger faster, that y equals 2x squared is actually going to be narrower. And so if a bigger number, like 2, makes it narrower, wouldn't a smaller number make it wider? Of course. So if I go y equals 0.5x squared, you're going to get something like this. So when a is greater than 1, the parabola gets narrower, it gets skinny, it compresses. When a is a small number, like less than 1, closer to 0, it gets wider. Well, now what about when a gets into the negative? We know that that flips it upside down. Well, the same kind of rules applies. If it's more negative than, so here's our kind of perfect y equals negative x squared. So if it goes more negative than just that negative 1, then it's going to be a little bit steeper. So we might have something like this for y equals negative 2x squared. And we might have something wider like this for y equals negative 0.5x squared. So as you can see, a does two things to a parabola. First of all, when a is positive, the parabola points upwards. When it's negative, it points downwards. So smile and frown, that's easy to remember. And secondly, a can compress or stretch a parabola, and the bigger the number, or the further away from 0, from 1 or negative 1 it gets, the narrower it gets. And when it's between 1 and negative 1, when it's a tiny little number, it actually makes the parabola even wider. And that's what a does to a parabola in vertex form. So that's what this part does in vertex form.